So today we are going to see about the two transistor analogy of SCR. So it's an important question in this unit. So the operation of SCR is studied with the help of the operation of the two transistors. So the transistor can be analyzed as two transistors and one NPN transistor and one PNP transistors. With the help of that we can analyze the operation of the SCR. So here we can see, so already yesterday we have seen the construction of SCR. It is a 3-terminal 4-layer 3 junction device. So the 4 layers are PN and PN, 2 P-type layers and 2 N-type layers. So here have the first diagram is represents the schematic diagram of the SCR. So here we are having the 4 layers PN and dotted line which will bisects the inner 2 layers so that it can be bifurcated into 2 transistors. So the first one is the PNP transistor, that is Q1 is PNP transistor and the Q2 is NPN transistors. So these transistors are interconnected so that we can analyze the operation of these two transistors. So first one, we can see the anode current, gate current and the cathode current. So this is the currents of the SCR. So in the third diagram it can be represented by the transistor currents. So the anode current IA will be equal to the emitter current of the Q1 transistor, and IG, the gate current, will be equal to the base current of the transistor Q2 plus the collector current of the transistor Q1, and the cathode current IK will be equal to the emitter current of Q2. And here we are having the gains alpha and beta. Alpha is the common base gain and beta is the common emitter current gain. So common base current gain means alpha will be equal to IC by IE, and beta is the common emitter current gain which will be equal to IC by IB. So these things already we have studied in the electronic circuits. And what are the similar currents we can analyze from this third diagram means the base current of the first transistor will be equal to the collector current of the second transistor, that is IB1 is equal to IC2, and the the base current of the transistor Q2 will be equal to IC1 plus the base current of Q2 will be equal to IB2. So that is nothing but the gate current which is applied from the outside and the collector current from the transistor Q1, and IK is equal to IE2 and IA is equal to IA1. So these are the some of the current expressions we can derive from this equivalent circuit of this SCR. So from this we have to derive the anode current IA. So these are the expressions to be calculated. So first one, the IC will be equal to alpha times IE. So that is alpha is equal to common base current gain, that is alpha is equal to IC by IE, and ICB naught is the common base leakage current of the transistor. And from this expression we can have the IC is equal to alpha into IE plus ICB naught. So this expression can be used for writing the IC1 and IC2, that is the collector current for the first transistor and collector current for the second transistor. IC1 is equal to alpha 1 into IA plus ICB01. So here the IE is nothing but the anode current, that is the first transistor emitter current will be equal to the anode current of SCR, so that the IE1 is replaced by IA, and ICB0, that is equal to first transistor, it is taken as ICB0 1, and alpha 1 is the common base current gain of Q1, and the next one IC2 is equal to alpha into IE2 plus ICB0 2, and IE2 is nothing but the cathode current of SCR, so that IE2 is replaced by IK, and here also alpha 2 is the common base current gain of Q2 and ICB0 is the common base leakage current of Q2, and Ik is the emitter current of Q2, and Ia can be written as, from this diagram, Ia can be written as IC1 plus IC2. So that is, by using the Kirchhoff's current law, we can write it as Ia is equal to IC1 plus IC2. So on substituting the above two expressions for IC1 and IC2, we will get alpha 1 into Ia plus IC B01 plus alpha 2 into Ik plus IC B02. So from this we can rearrange some terms, so that Ia is equal to alpha 1 into Ia plus IC B01 plus alpha 2 into Ik, that is the cathode current, can be written as Ia plus Ig. That is, by using the Kirchhoff's current law, we can write the cathode current will be equal to anode current plus gate current plus IC B02. So from this we can have the anode current expression as, and rearranging the terms we will get the expression as alpha 2 into Ig plus IC B01 plus IC B02 divided by 1 minus alpha 1 plus alpha 2. And if you are not understanding this in few steps, means it can be elaborated. So here the IC is the collector current and IE is the emitter current, and IC B0 is the forward leakage current, and alpha is the common base forward current gain. And the relationship between IC and IB is, IC is the beta times IB, where beta is the common emitter current gain, that is beta is equal to IC by IB, and IB is the base current and IC is the collector current. So here IB, beta is the common emitter forward current gain. So for the transistor T1 we can write the IC1 is equal to alpha 1 into Ia plus ICB01, and for the transistor T2, that is Q2, here IC2 is equal to alpha 2 into Ik plus ICB02, and again IC2 is equal to beta 2 into IB2. So now by the analysis of two transistors model, we can get the anode current as Ia is equal to IC1 plus IC2 by applying the Kirchhoff current law. From the equation 1 and 2 we will get Ia is equal to alpha 1 into Ia plus ICB01 plus alpha 2 into Ik plus ICB02. So if applied gate current is Ig, then cathode current will be the summation of anode current and gate current, that is Ik is equal to Ia plus Ig. By substituting this value of Ik in the third expression, we will get the expression as the Ia is equal to alpha 1 into Ia plus ICB01 plus alpha 2 into Ia plus Ig plus ICB02. So that we are getting the expression as we have discussed before. So from this relation we can assure that with the increasing the value of alpha 1 plus alpha 2 towards unity, so what will happen in the Ia? Unity means 1 minus 1, so that will Ia will reaches the infinity. So correspondingly the anode current will increase. So for ideal case we can increase the alpha 1 and alpha 2 towards the unity, so that the Ia becomes infinite. But in practical cases it will not be it will not reach unity, so that the Ia can be increased to sometimes, that is the by means of the factor alpha 1 and alpha 2. So now the question is how an alpha 1 and alpha 2 is increasing. So here is the explanation for the using the two transistor model of SCR at first stage. So here we can see, so we are applying the gate current, means for the in the third diagram we can see for by applying the gate current Ig, so that will gives the base current to the transistor Q2. So the transistor Q2 will be turned on, which in turn will give the IC2. So the IC2 is by means of a beta we can write it as IC2 is equal to beta times IB2. So that IC2 is applied as base current to the transistor Q1, that is IC2 is equal to IB1, so that the Q1 transistor will also be turned on. So by after turning on the transistor Q1, so that will give a current IC1. So the IC1 will again is applied as base current, or the base current to the transistor Q2, so that the gate current is again increased. So if the gate current is increased, means the input current, that IB2 is increased. So here we can see that IB2 is equal to Ig plus IC1. So if IC1 is increased, then correspondingly IB2 will be increased. Since Ig is a constant parameter and IC1 is now it is due to the turn on process of the Q1. So when the IC1 is increased, the IC1 plus Ig will be applied as base current to the IB2. So that will in turn will increases the IC2. That is by means of the amplification factor. IC2 is equal to beta 2 times IB2. Now the IB2 is increased, so that correspondingly the IC2 will increase. So the increased IC2 is applied as a base current for the Q1, that is IB1. So due to that increased base current, again the IC1 is again increased. So it is a positive feedback process, so that the current gain is increased. So at the last we can have the alpha 1 and alpha 2 reaches the unity, so that the IA, the anode current, will becomes the infinite one. So this is explained over here. So the first, when we apply a gate current Ig, it acts as a base current of the transistor T2, that is IB2 is equal to Ig at initial condition. Initial condition, there will not be any IC1, so that IB2 is equal to only Ig. And the emitter current of the transistor T2, that is IE2 is equal to IK. Hence the establishment of the emitter current give alpha 2 as ICB01 by Ig. The presence of base current will generate the collector current as IC2 is equal to beta 2 times IB2, and IB2 here now is it Ig, that is IC2 is equal to beta 2 into Ig. This IC2 is nothing but the base current of IB1 of transistor T1, which will cause the flow of collector current. IC2 is equal to beta 1 into IB1, that is beta 1 into beta 2 into Ig. Then IC1 and IB1 leads to increase IC. So here it is IC, it is not IC2, it is an IC1. IC1 is equal to beta 1 into IB1, and IB1 can be substituted as beta 2 into Ig, since IB1 will be equal to IC2. So IC2 already we have derived it as beta 2 into Ig, so that beta 1 into beta 2 into Ig is substituted over here. And IC1 and IB1 leads to increase the IA. Here is also a mistake, that is here increase the IA, that is IC1 plus IB1, and alpha 1 increases. Now new base current of T2 is Ig plus IC1, that is equal to 1 plus beta 1 into beta 2 into Ig, which will lead to increase the emitter current, and Ik is equal to Ig plus IC1, and as a result alpha 2 also increases, and this further increases IC2 is equal to beta 2 into 1 plus beta 1 into beta 2 into Ig. As IB1 is equal to IC2, alpha 1 again increases. This continuous positive feedback increases alpha 1 plus alpha 2 towards unity, and anode current tends to flow at a very large value. So the value of current then can be controlled by some external resistance of the circuit. So this is a graph drawn between the current gain alpha and the IE. So when the alpha is approaching the unity, the current, anode current, will be the emitter current or the anode current. So here we can see the emitter current of the transistor Q2 is the cathode current, and here the anode current will be equal to the emitter current of Q1. So here it is drawn between the anode current and the current gain alpha. So here you can have it, this is anode current of Q1 or the emitter current of anode current of SCR or emitter current of Q1. So IA is equal to, that is alpha 2 into Ig. So this is the expression already we have derived. So when the alpha 1 plus alpha 2, the current gain reaches the unity, the current will be increased in a very high value. So this will increases the anode current. So this is the turn on process of the SCR. Thank you.